Hi, I am Ganesan and now we are going to discuss about a small topic in evaluation of Nacelle drag using CFD. Before entering into the Nacelle drag using CFD, we are in need to know what is the drag which is carried out and what is the performance which affects the performance of the aircraft. Before entering into it, we just discuss about what are the aerodynamic drags which is carried out in this project with respect to the internal as well as the external drag. Now, the performance of the aircraft is based on the drag which is drag as well as with respect to the lift. Here we are just going to discuss about the main feature as a drag which is affecting the performance of the drag. Here the aerodynamic drag is classified into viscous drag, induced drag and the wave drag. Here the viscous drag is consists of a skin friction drag which creates a drag within the internal structure, that is in the sense starting from the lip structure, lip of the nozzle structure to its outer, that is the throat, outer throat, that is the exhaust throat of the nacelle. The internal structure of this part has been facing a skin friction which leads to a drag. Whereas in induced drag, here the here it consists of a distribution of pressure, a variation of distribution of pressure over the nacelle is concentrated in induced drag. Whereas in wave drag, here the pressure distribution as well as the shock waves which is acting over the surface of the nacelle, that is the external area of the nacelle, is being we are just studying using wave drag. Here with respect to the internal external pressure distribution of the drag, the drag is calculated with respect to the aerodynamic drag. Here with respect to these three classification, drags are being calculated and the further studies are carried out with respect to the performance of the nacelle. Here this is the now we are going to here the graphical representation of a nacelle is shown here with respect to the flow of the internal as well as the external flow. Here the flow which is going inside the nacelle structure is known as the internal flow, and the split of the external flow, that is in the sense the air which is flowing inside the nozzle with respect to the fan which absorbs the air from the nacelle lip. Here there is a split between there is a split in the nacelle structure which helps us in splitting up the air which is being extracted inside the engine. Some of the air enters into the engine, whereas some of the air it gets being subjected outside the nacelle, which helps us in a drag. Here the gases which is flowing outside the nacelle is known as the external flow, that is the external drag which is carried out, whereas the internal flow, here the gases, that is in the sense the air which is flowing inside the nacelle, is known as the internal flow. Usually based on the flow only, the drag as well as the thrust loss is being calculated. The flow which is carried out inside the nacelle structure is known as the which leads to a thrust loss, whereas the air flowing outside the nacelle structure leads to the drag. Here with respect to the internal and external flow of the air only, here the drag as well as the thrust loss is being calculated. Here now how we are calculating the internal drag and how we are going to calculating the external drag with respect to the CFD. CFD is the tool which we can it is a mathematical tool which we can analyze with respect to the flow of the fluid or air with respect to their motion. Thus, in the sense, the actual flow of the air which is passing through the nacelle inside, or the external air which is flowing through the nacelle, is being calculated mathematically with respect to some equations which is carried out in the CFD analysis, so that here the analysis part can be done with respect to the airflow and the results can be obtained before going for a production itself. CFD it is a powerful tool which we can use and we can analyze the actual flow rate with respect to a laminar or turbulent flow, with respect to the flow of the air, how the performance of a nacelle helps us in improving the performance of the aircraft. With respect to internal drag, here the air which is flowing inside the nacelle, that in the sense the internal core, whereas the internal drag starting from the lift section to the exit of the nacelle. Here the concentration which is carried out inside the nacelle, Here it has been evaluated and it is been analyzed with respect to the certain flow, with respect to the certain velocity of with respect to the Mach number, with the variation in the Mach number and with the variation of Reynolds number, with respect to the laminar or turbulent flow, in the sense with the external or internal flow. Here with the internal drag is calculated. Now it can also be calculated analytical method using the fixed formula, that is in the sense integral of S is equal to R U V vector plus P minus T infinity into I vector minus Tx vector into N vector ds is equal to 0. Using this formula, you can find out what is the drag, that is the way of analytical way of calculating the drag which is which produces the nacelle, which causes the nacelle drag. Here with respect to this formula, it has been separated into two formula. Here the before formula which we have discussed has been decomposed into two different formula with respect to LHS and RHS. If we are going to deal with the integral formula of the with respect to the left hand side, it leads to a near field method, whereas if the integration formula is carried out with respect to the RHS, here the far field method is carried out. Here with respect to the left hand side and as well as the equation which is carried out with respect to the left hand side as well as the integration method which is carried out with respect to the RHS leads to the calculation of the drag with respect to the viscous as well as the wave drag. Here now we are going to discuss about the far field method with respect to based on far field method is nothing but it is actually based on the Van der Waals method with respect to the viscous drag as well as the wave drag. Here now we are going to discuss about the far field method and how it helps us in finding out the drag with respect to the nacelle and how does it cause it affects the performance of an aircraft. Here now the analysis part is carried out with respect to the internal as well as the external part of the nacelle. Here first the analysis part is carried out using CFD. Here the drag extraction of a nacelle is carried out in three cases, that in the sense the 2D analysis with respect to the DLR F6 nacelle as well as the 3D analysis of a load duct nacelle with different contraction ratio as well as a third 3D analysis of a wind tunnel model internal drag. Here the analysis part is carried out at this with respect to these three model and it is calculated with respect to the near field method as well as for far field method. Now we are going to discuss about the 2D analysis of DLR F6 nacelle, which is used for the purposes of calculating drag with respect to the nacelle. Here the 2D analysis helps us in finding out helps us in meshing the outer structure as well as the internal as well as the outer structure. Either one of the process can be carried out, whether if you want the internal flow of the gas which is passing into the nacelle or the flow which is carried out within the nozzle can be calculated using the internal flow. If the external, if we are needing finding out the external flow which is carried out outside the nacelle is to be with respect to the drag can be calculated using the 2D analysis of DLR F6 nacelle. Here with respect to the 2D analysis DLR F6 nacelle, which we are already been aware of, that in the sense we are already an experiment has been conducted with respect to the near field method as well as the far field method. Here we are going to discuss about the graphical representation with respect to the near field method as well as the far field method. Here the graphical representation shows the nacelle drag coefficient with respect to the Mach number. Here the analysis is carried out by varying the Mach number based on the speed as well as with the drag coefficient. Drag coefficient with respect to the drag coefficient and the Mach number, the graph is plotted. Here with near field method, the graphical representation of a near field method is shown at the upper face, whereas the far field method is shown at the lower face. Here the differences between the far field as well as the near field. The near field is near field method which states above position over the far field method in the case, whereas both of the near field as well as the far field method are intersecting at a point. Here, the variation at the increase in the Mach number, the graphical representation represents since the drag is increasing due to the increase in the Mach number. Here, there is a variation between the near field method as well as the far field method due to the finite trailing edge. Due to the finite trailing edge, there is a variation between the near field method as well as the far field method which is carried out. Here, at the point there is an intersection where the both of the drag is equal in the sense here which is carried out using the that in the sense it is caused due to the external nacelle exterior, that in the sense the exhaust of the nacelle, because in the sense it has been there is some of the force which is acting some of the force in the sense the shock load which is acting at the exterior portion of the nacelle. Here, this is the region where both of the near field method as well as the far field method is intersecting at a point, so that a drag is equal at this area. With respect to the Mach number and the drag coefficient, the drag with respect to the far field as well as the near field method explains us a better way how the drag is carried out with a change in Mach number with respect to this some speed. Then another experiment is conducted with respect to the force which is acting, in the sense the pressure which is acting on the outer surface of the nacelle. Here, the exact nacelle is being subjected to the wind tunnel section, whereas here the three kinds of nacelle has been used with different diameter of the nacelle, that is in the sense the throat dia. Here, with respect to the contraction ratio. Contraction ratio is the ratio of the area from the throat diameter of the nacelle as well as the exit of the nacelle. Here, three contraction ratio of three different nacelle has been calculated. One is the with respect to three different contraction ratios. Here it has been tabulated and three nacelles have been subjected for the analysis part. Here, with respect to the nacelle which is exposed to the atmosphere, that in the sense the fluid flow, the only small amount of variation is carried out at the outer surface of the nacelle. So it is subjected to have a circular ring over the nacelle, that is the outer surface, which has been here shown graphically with respect to the green color. Here, when the fluid flow occurs at this region, due to the increase of the radius, because we are just varying the diameter of the nacelle. So, due to the increase of the nacelle structure, we are considering about the 3 model. Due to the increase of the radius of the nacelle structure, that is in the outer side of the ring, leads to a increase in the drag. So that the nacelle, this graphical representation will represent how the drag is carried out with respect to the outer ring, which is outer ring with respect to drag, and with increase in the drag with increase in the radius. This shows how the drag is carried out with respect to increasing the outer area, which stops, that in the sense which produces a drag to the nacelle structure as well as the aircraft, which spoils the entire performance of the engine. Here, with that analysis of these 3 contraction ratio with respect to the different Mach number and the Reynolds number, here the graph has been plotted, and the this is the graph which is showing the comparative results of the drag or different geometries. In this sense, the variation of the diameter of the nacelle with the 3 contraction ratios. Here, with respect to the radius, here the first nozzle with the lesser radius gives a very good performance when compared to the other 2 nozzles. Here it is so much useful in finding out how the fluid flow which is being concentrating on the outer surface of the nacelle, so that how it produces a drag with respect to the increase in the radius of the nacelle structure or the outer side of the nacelle, how it is being carried out with respect to the nacelle wind which is flowing inside. Then another analysis is carried out what is the process which is going, that in the sense the fluid flow which is carried out internal, which produces the internal drag. Here the graphical representation of internal drag is shown here with respect to, here the air is flowing within, inside the nacelle structure, that is in the sense, here the green color represents the airflow within the nacelle structure. Here this represents with respect to different, this analysis is carried out with varying the Mach number and with respect to the Reynolds number. Here the Reynolds number is taken with 3 to 10 power 6. With respect to this Reynolds as well as the varying the Mach number, the internal reactions which is carried out due to the fluid flow is calculated using the internal drag, using this internal drag with respect to the force flow as well as the near flow method. Here, at the conclusion, we are just finding out where the more drag is carried out and at what region the drag which is carried out at the interior region, and at what areas the drag is more when compared to the other two methods which we are calculated the exterior drag which is carried out, as well as here we are finding out what is the inside drag which is carried out. When the airflow inside, it is being subjected that there is a split between the airflow which is flowing into here. So most of the split is carried out at this region before entering into the exhaust of the nacelle structure. So it represents as well as it confirms that that more of the split is carried out. That in the sense the drag is not carried out with respect to the shock loads which is applied to the nacelle structure, whereas due to the atmospheric pressure, whereas the most of the drag is carried out with respect to the split between the internal as well as the external airflow or a fluid flow which is carried out in a nacelle. With this, a confirmation or and as well as a development process is carried out with respect to the reduction in the drag in the aircraft engine, and now we can get a ideal information as well as get a information about how the drag helps us in increasing or decreasing the efficiency of the aircraft. The knowledge which I have discussed till now based on the study on the nacelle structure as well as the study on the nacelle design with respect to the CFD analysis as well, and with respect to the masters which I have finished in product design and manufacturing, and I have 1 year of experience in designing of heavy components as well as some of the I have 3 months of experience in the sense with respect to CAE as well as the CFD tool. So it will be helpful for me if in order to find out what is the actual process going in, so that I can share what is the final process carried out with respect to the drag using evaluation of nacelle drag, and using CFD drag you can get a better information with respect to my presentation. Thank you.